I'm Jim King. Thanks for coming out to listen to me today. I'm going to talk about the fluid mechanics of renewable wind energy and how it's going to affect your life in the years to come. So I went to a talk yesterday about sustainable energy, and this was one topic that came up, kind of interested me. Just a couple little facts. Renewable energy is energy that comes from resources that are naturally replenished in human timescale. So that includes rain, tides, or sunlight, things like that. And then 16% of our global energy is actually renewable energy sources. Okay, so a wind turbine. This is what one looks like. Up there you can see number 1 is your blades, or number 1 and 3 around there. Number 2, that's your rotor, and that's what the wind actually pushes on and begins a rotation and cranks all the shafts and eventually charges or pumps energy into a generator, heads down the support beam, and is transferred from kinetic energy into your electric energy, like right there. Okay, so the aerodynamics of it. What happens is when your wind flows over one of your blades, it creates a pressure difference, and the difference is uneven, creating a higher pressure on one side and a lower pressure on the other, and that generates this spinning motion between your propeller up there. When that happens, the blades circulating, or the revolutions, create about 18 revolutions per minute, which seems small in the grand scheme of things, and you think you wouldn't get that much energy out of it. But looking back at our previous diagram, all of these gears and the crankshafts end up multiplying the revolutions per minute nearly 100 times that. So what's originally 18 revolutions per minute turns into about 1,800, and that's where you gain all your energy in your generator. In the picture up here, you can see, like others have talked about, it depends on 2 equations, your drag and your lift. And like people said before, the formulas are basically the same. It's your rho, which is the air, density of the air, over 2 times your velocity squared. And then the area here is your area of the wind times a constant of lift, or a constant of drag, and then times the angle that the wind is actually hitting the propeller, as you can see. Up top, that is just a picture or an image of a program that is used to design these specific blades to create the most aerodynamic effect and get the most bang for your buck, really. So when looking at it, this is kind of just like a grand scale. When you have a wind farm, the energy is transferred down and then put into power lines, harnessed as electrical energy. You can power up to one wind farm, which is about 25 of these at 50 megawatts, can power up to about 40,000 homes. So it seems like a lot. And the flow is dependent on, certain things. Some of these are placed out in the ocean, and it depends on bodies of water or vegetation or the different types of landscape. Okay, so this was one advancement in turbine, and they ended up using or replicating tubercles on whale fins. And what they did was they looked and saw how aerodynamic whales had become and how they can move quickly even though they had such a large body mass. And they harnessed that idea and created blades that focused on the same aspects of that turbocoil, which it would produce a more efficient turbine, and ended up reducing the onset of stall, which could result in a failure for the turbine, and then a windmill technician would have to perform a very dangerous profession and try and fix it. So that it's kind of interesting. This design actually was designed in SolidWorks, so I'm sure we all know about that. Okay. Some of the benefits are engineering security. You can harness the energy. You don't have to worry about burning fossil fuels, obviously. And economic relief, which is still debated upon because these turbines are so hard to actually create and set up in an environment. And then climate change mitigation, that's more for global warming, and that's your own kind of topic. But okay, some of the risks now, these are huge, huge inventions. They're 400 feet tall, weighing nearly 400 tons, and to set up a farm with 25 turbines can be roughly 4,000 acres. So it takes up a lot of space. You're not going to want to put this anywhere near anybody living in the area. It's loud, and they can be dangerous. As you can see, there's an explosion there, which is why the job as a windmill technician is so risky. Okay, I just have a little video to show you guys. This was one of these wind turbines that actually failed. So imagine your house is over here. You're not in very good shape, and you can see how heavy it actually was when it hit the ground. How much debris flew out in the air. But you can see the fracture point as well. And that would be it.